friends, this is Dr.V Siva Nagaraju from IARE. Today's topic is RF section and characteristics of a receiver. In previous classes, we discussed what is the receiver and what is the duty of the receiver and types of receivers like TRF, tuned radio frequency, and super heterodyne receivers. So in these two receivers were having RF section. So now we are going to briefly discuss what that RF section and what are the characteristics of a receiver. So this is going to discuss in this session. Okay, coming to the topic, this is our super heterodyne AM receiver block diagram. So here you can see the first antenna which collects the signal and sends to RF section. And after RF section, we're having a mixer. So the mixer which converts the signal and having a local oscillator which produces a frequency of F0. Then after mixer, the signal which enters into the IF section. Already know what is IF, intermittent frequency. And finally, it enters to the envelope detector where the original signal is detected and sent to the speaker after some amplifying process. So, in any receiver, the RF section is there. So, what the RF section and what it having and how the signal is going to couple with this section is all going to discuss. Okay. So RF section. A radio receiver always has an RF section. Why? Because it may be a TRF or it may be a super heterodyne. The RF section is must. So this RF section, which is a tunable circuit connected to the antenna terminals. Why? Because before this RF section, we're having antenna. So this section, this RF section must be tuned with this antenna. Otherwise, this selection of the signal is not possible. So this RF section, which is a tunable circuit connected to the antenna terminals. So it is there to select the wanted frequency and reject some of the unwanted frequencies. Why? Because we're not having only the signal, we're also having noise. There is unwanted frequencies. Number of signals is going to adding with our signal. So we are going to select our desired signal. So that is to select the wanted frequency and reject some of the unwanted frequencies. So here this RF section is comprises into three blocks. One is input tune circuit, RF amplifier, and output tune circuit. So once again, we are going to remember the block diagram of super heterodyne receiver. So first we're having antenna, then after we're having RF section, and then after we're having mixer. After mixer, we're having IF, intermittent frequency block. So here we're having the local oscillator. So here we are dealing with this RF section. So the RF section which comprises with input tune circuit, RF amplifier, and output tune circuit. So the input tune circuit which is going to connect it with this antenna. So this one is our antenna. This is our antenna. So the input tune circuit, which is going to connect it to the antenna terminals. So this tune circuit, which is going to tunable with this antenna, then the selection of the signal is good. Okay. After RF section, that means after input tune circuit, we are having RF amplifier. So here we are going to amplify the signal. And then after we are having output tune circuit. So this output tune circuit, which is going to connected with this mixer. So the duty of the output tune circuit, which is going to tunable with this mixer. Why? Here the frequency conversion is done in the mixer. Why? Because here the signal which is coming through the antenna and passes the RF section, we having the signal frequency Fs. This is our signal frequency. And here we are getting F0. The F0 which is coming from the local oscillator. So here these two signals which is going to mix it. So the frequency conversion is done. So here the IF, that is intermediate frequency signal, which is equal to F0 minus Fs. This is our intermediate frequency. So the intermediate frequency, which is equal to F0 minus Fs. So generally this IF is a low fixed frequency. So it having low. So this output tune circuit, after the output tune circuit, we are having mixer. So these are the important blocks of the RF section. Why? Because this RF section is very, very important to any receiver. So next one is RF amplifier. Why? Because in this RF section, we're having two tune circuits. One is input tune and another one is output tune. The middle one is the RF amplifier. So what is the RF amplifier? RF amplifier is a small signal tuned amplifier with the tune circuits both in the input side and the output side. So the middle one is the RF amplifier. So accordingly, the tune circuits select the desired carrier frequency and reject all undesired frequencies, including the image frequency. But actually, superheated receiver, which is suffering from this image frequency. Okay. So this parallel output tune circuit is tuned to the incoming desired signal frequency. The output from the receiving antenna is transformer coupled to the base of the transistor. So here this RF section, which comprises with the input tune circuit, RF amplifier and output tune circuit. So now we are going to discuss RF amplifier. So what is the block circuit diagram of the RF amplifier, and what is the description of this RF amplifier, and what are the advantages of this RF amplifier is going to discuss. So this is a circuit of RF amplifier. So here you can see the antenna, receiving antenna, which is having this coupling, and again one transistor is there. And after this RF section, the signal is going to the mixer. So in that circuit also you can see the mixer frequency mixer, which converts the frequency. So having a antenna coupling capacitor, antenna trimmer, RF tuning capacitor, and a signal decoupling network. So these are the circuit of this RF amplifier. Now we are going to discuss this description of this RF amplifier. Okay. So basically, this RF amplifier is a small signal amplifier using parallel tune circuit as the load impedance. So this parallel output tune circuit is tuned to the incoming desired signal frequency. The output from the receiving antenna is a transformer coupled to the base of the transistor. So in this picture, we can see. So it is connected to the base of the transistor. Here we can see. Okay. And the secondary coil of the input tune circuit is tuned to the incoming desired signal frequency with the help of ganged tuning capacitor. The help of ganged tuning capacitor. Already you discussed what is the ganging. So it is nothing but a mechanical coupling. Mechanical coupling. So in addition to this, small trimmer capacitor are connected in shunt with these tuning capacitors for the purpose of RF alignment. RF alignment. So this is the description of this RF amplifier. And the transistor, the resistors R1, R2, which is going to provide self bias. So a self bias is provided with the help of R1, R2, and RECE assembly. So already you can see in this circuit diagram, these resistors and capacitors which is going to connect, and a decoupling network consisting of resistor RB and capacitor CB is placed in the collector supply load. So in the circuit diagram, there is a decoupling network which is going to connect it at the collector of the transistor. So the amplified RF signal developed across the collector tune circuit is coupled to a step-down transformer to the input of the frequency mixer. Okay. This step-down transformer provides the impedance matching between the high impedance of the RF amplifier collector circuit and the low impedance of the base to emitter circuit of the following stage. So in this circuit diagram, we can see the transformers. So the step down transformer provides the impedance matching between the high impedance of the RF amplifier collector circuit and the low impedance of the base to emitter circuit of the following stage. Next, what are the advantages of RF amplifier? Why? Because in any receiver, this RF section is very, very important. Either it is a TRF or super heterodyne receiver, this RF section is there. So in the RF section, we must having RF amplifier. So what are the advantages of this RF amplifier? The first one is greater gain. So we are having greater gain. There is a better sensitivity. Why? Because here one of the characteristics of the receiver is the sensitivity, and another one is selectivity. So these two are the very, very important characteristics of any receiver. And second advantage of RF amplifier is improved image frequency rejection. And third one is improved signal to noise ratio. And another one is improved rejection of adjacent unwanted signals. It is better selectivity. So this first and fourth advantage is very, very important. Sensitivity and selectivity of a radio receiver. These are the characteristics of the radio receiver. Why? Because our signal is mixing with a number of signals. We are going to identify and we are going to selected signal. So it is very, very important. And at the same time, we are going to reject the adjacent unwanted signals. So nearby signals, nearby frequency, the signal which is going to try to enter into a receiver. So we are going to reject that unwanted signal. Okay. And another advantage of RF amplifier is better coupling of the receiver to the antenna. Better coupling. Why? Because we are going to couple with that antenna, then we can get the maximum signal. So, not get better coupling. What happens? The signal is not collected by the receiver or received by the receiver. So, this is very, very important point of this sort of amplifier. Better coupling of the receiver to the antenna. Why? Because antenna is the first part of this receiver. So any receiver having that antenna, by using that antenna, signal is going to collect it. So here the coupling is not good between this antenna and the receiver. How the signal is collected? So that's why the RF section having input tune circuits. By using the input tune circuit, this receiver which is going to couple with that antenna, then we are getting better coupling and good receiving. Okay. And another advantage is prevention of spurious frequencies from entering the mixer and heterodyne produce interfering frequency equal to the IF from the desired signal. So it's just like a base frequency. So we are going to prevent of these spurious frequencies from entering the mixer and heterodyne. Why? Heterodyne means it is going to mixing. So what we are going to mixing, I already discussed. What that one? The signal frequency which is going to mix it with our local oscillator signal frequency, then producing IF. It is intermediate frequency. So this RF amplifier is very, very important in the receiver. And another advantage is prevention of re-radiation of the local oscillator through the antenna. Why? Because we're having the local oscillator where in the mixer section. So by using that local oscillator, it may be having re-radiation. So this RF amplifier which is going to prevent that re-radiation also. Okay. So these are the advantages of RF amplifier. And coming to the sensitivity. So what the sensitivity? These are the characteristics of the receiver. One of the characteristic of the receiver. So now what is the definition of the sensitivity? The sensitivity of a radio receiver is its ability to amplify weak signals. The sensitivity of a radio receiver is its ability to amplify weak signals. Why? The signal is coming from a long distance. So this signal is going to disturb with another signals and is going to distort it. So fading is coming, then the signal amplitude is going to reduce. So finally it reaches a receiver. So the sensitivity of a receiver is its ability to amplify weak signals. Means the weak signal what we are receiving, we are going to amplify. That radio receiver must have that ability. It is going to amplify that weak signals. Generally, any receiver getting weak signal. So it is in the range of milliwatts, micro, volts. So like that, it is coming very, very less signal. That means very weak signal we are going to amplify. So that is the important characteristic of the radio receiver. So it is often defined in terms of the voltage that must be applied to the receiver input terminals to give a standard output power measured at the output terminals. Okay, so this is a definition of the sensitivity. So this is our sensitivity curve. This is our sensitivity curve. So generally the sensitivity in microvolts, and here the x-axis is the frequency. Frequency is in kilohertz. So in this curve it can show from 600 to 1600 kilohertz frequency, and the sensitivity is in y-axis, so it is from 10 to 16. That means here the frequency is varying. You can see first is initially it is 600 kilohertz. Now after the middle one is 1000 kilohertz, and then after having to 1600. So here it's changing. Whenever the frequency is going to increasing, sensitivity curve is also varying. So this is our sensitivity curve. So the sensitivity is often expressed in microvolts or in decibels below 1 volt and measured at 3 points along the tuning range when a production receiver is lined up. So the sensitivity curve shows that sensitivity varies over the tuning band. So in this picture, here this tuning band is from 600 to 1600 kilohertz. Okay. Why? Because if any receiver having a tuning range, so in the tuning range, the signal is going to detect. Okay. So in that particular frequency band, this receiver having the ability to amplify the weak signals. Okay. So this is sensitivity. And now for the professional receivers, the sensitivity is generally quoted in terms of signal power required to produce a minimum acceptable output signal with the minimum acceptable output noise level. So a few factors determining the sensitivity of super heterodyne receiver. Why? Because nowadays we are using super heterodyne receivers. So our focus is only on this super heterodyne receiver, not on TRF. Okay. So what are the factors? The gain of the IF amplifier. Why? Sensitivity is very, very important characteristic of a super heterodyne receiver. So which is going to determine this sensitivity? So here we're taking a few factors. So the first one is the gain of the IF amplifier. Why? Because in RF, after RF amplifier having mixer, then IF. The super receiver having IF amplifier. So the gain of the IF amplifier is also determine the sensitivity of the super receiver. And another one is the gain of the RF amplifier. And finally, the noise figure of the receiver. So these three factors determining the sensitivity of a super heterodyne receiver. Okay. So one of the important characteristic of the receiver is discussed, and another one is selectivity. So in practical, what are the sensitivity values here were given. That is, the typical values of sensitivity are 150 microvolts for small broadcast band receivers and 1 microvolt for or below 1 microvolt or below for high quality communication receiver in the HF band, high frequency band. So these are the values, sensitivity values for the practical receivers. One is a broadcast band receiver, and another is a communication receiver. Here we give it. Okay. And after sensitivity, we are having selectivity. So this selectivity also very important characteristic of the receiver. So selectivity is the main factor which determines the adjacent channel rejection of a receiver. Okay, selectivity is the main factor which determines the adjacent channel rejection. Why? Because we're having a number of signals which is nearby our desired signal frequency. So the receiver has the ability to reject all the signals. Okay, so selectivity is the main factor which determines the adjacent channel rejection of a receiver. And another one is the definition. The selectivity of a receiver is its ability to reject unwanted signals. That is, unwanted signals are not required a signal. So the receiver which is going to reject all those signals. It also expresses the attenuation that the receiver offers to signal at frequencies adjacent to the one to which it is tuned. Why? Because our receiver having a tuning range. So in that tuning range, our signal is going to select, the desired signal is going to select, and the unwanted signals is going to reject. So that is the important abilities of the receiver. In selectivity measurement, the frequency of the generator is varied to either side of the frequency to which the receiver is tuned. The output of the receiver naturally falls since the input frequency is now incorrect. So when you take a radio, so how this tuning is going to done? That means we are going to rotate that knob for which the station is required. Okay, so the particular station is going to audible for the listeners. So that means here the receiver has the ability to reject all unwanted frequencies. Okay, so thus the input voltage must be increased until the output is same as it was originally. So the ratio of the voltage required of resonance to the voltage required when the generator is tuned to the receiver's frequency is calculated at a number of points and then plotted in dBs to give a curve shown in figure. So here we're having selectivity curve. So here you can see this selectivity curve. Yeah. So the receiver tuned to 950 kilohertz. So this is a typical selectivity curve. So in that range, the signal is going to selected, and out of that we are going to reset. Okay. So here you can see the attenuation and ABC in y-axis, and in x-axis that is generated detuning kilohertz. Okay. Now, the selectivity depends upon the following factors. Already we've seen that sensitivity, which determines some factors. So here also some factors we're checking. So the first one is selectivity varies with the receiving frequency and becomes somewhat worse when the receiving frequency is raised. And in general, it is mainly determined by the response of the IF section with mixer and RF amplifier input circuits playing a small but significant part. This is the second factor. So selectivity is the main factor which determines the adjacent channel rejection of a receiver. So these are the factors which the selectivity depends. Okay friends, here we are going to one example depends on this super receiver of image frequency and rejection ratio. So in this problem, first we are going to see that problem, what is given. In a broadcast super heterodyne receiver having no RF amplifier, the loaded Q of the antenna coupling circuit is 100. If the IF frequency is 455 kHz, find the image frequency and rejection ratio for tuning at 1 kHz. And second one is the image frequency and rejection ratio for tuning at 25 megahertz. So this is a given problem. We are going to find the image frequency and rejection ratio for the given tuning frequencies. Okay. So first let us take the given data for solving this problem. So here the given Q factor is given, that is 100, and FIF is given, that is 455 kHz. So first we know the formula of image frequency. So that is FSI, which is equal to Fs plus 2Fi. Why? Because we know that Fs is the signal. What is the signal frequency? For the first one, why? Because in this problem they given 2 bits. In the first bit, it is in the first bit, this signal frequency is 1 kilohertz. Signal frequency is 1 kilohertz. So here you taken Fs value is 1 kilo and interval frequency Fi or FIF, or it may be, it is for 55 kilohertz. So of knowing the formula, we are going to substitute these values. It is FSI, which is equal to Fs plus 2Fi. So here the Fs is 1K plus 455K, that is Fi. So substituting these values, so we are having FSI is 1000 plus 2 into 455. So this FSI image frequency is 1910 kilohertz. And this rho. Why? Because here the rejection ratio, image rejection ratio, that is defined as alpha, which is equal to 1 plus square root of 1 plus q square rho square. So for finding rho, why? Because q is given already. Q is given. So we are going to find rho. So rho value is Fsi by Fs minus Fs by Fsi. So we know that Fsi value and substituting, and we know the Fs value again by using calculus. We could calculate that Fsi by Fs minus Fs by Fsi. You get rho value is 1.386. So this alpha, image rejection ratio, which is equal to square root of 1 plus q square into rho square. 1 plus q square into rho square. So after substituting all these values, getting alpha value is 138.6. For the second bit, Fs is 25 megahertz. Fs is 25 megahertz. So the formula is set. There is Fsi, which is equal to Fs plus 2 Fi. So here Fs is in megahertz. So we convert Fi. Why? Because Fi is 455 kilohertz. Yeah, this one. Here Fs is 25 megahertz and Fi is 455 kilohertz. So we're converting this kilohertz into megahertz. Our intermediate frequency value is 0.455. So here we're going to substituting these values, getting Fsi, image frequency. So the image frequency is 25.91 megahertz. And another one is we're going to find rho. Why? Because we know that alpha which is equal to square root of 1 plus q square into rho square. So much should we going to find this rho value. So the rho is Fsi by Fs minus Fs by Fsi. We know that Fsi value, Fsi is 25.91 and Fs is 25 megahertz. So both are in megahertz. Fs is in megahertz and Fsi, it is image frequency. Imaging frequency also is megahertz. So 25.91 divided by 25 megahertz is going to cancel, minus Fs 25 divided by 25.91 megahertz. So here also megahertz is going to cancel. So of substituting Fsi by Fs, you're getting its value is 1.0364 minus Fs is 25 divided by 25.91. So after solving this factor, we're getting 0.9649. So finally, the rho value is 0.0715. 0.075. So after getting this rho value, we are going to substitute in alpha rejection ratio. That is alpha, which is equal to square root of 1 plus q square into rho square. So we know that q value, it is given as 100, and going to substitute this q value and rho value. So once again, you're going to see this q value is 100. Yeah, q value is 100. So here we are going to substitute this q value 100 square into this rho square, that is 0.0715 whole square. So by using calci, you can calculate this value we're getting alpha is 7.2195. So this is our image frequency rejection ratio of that particular receiver at that particular band. So why? Because here they given the tuning range is 25 megahertz. So at that 25 megahertz, this rejection ratio is 7 point. Whereas again, the previous one, it is given as 1 kilo. So here also, we're getting this rejection ratio. Okay.
Like, share and subscribe. Hit the bell icon for more updates.